Ever wondered if a single word could change our understanding of the universe? Let's take a journey into the world of physics and language where every word matters. Recently, Olhar Digital initiated a discussion about Newton's first law of motion, a law that has been a cornerstone of physics for centuries. This law, known to many as the law of inertia, states that objects in motion stay in motion, and objects at rest stay at rest unless acted upon by an external force. But wait, there's a twist in the tale. The controversy lies in a single Latin word from the original text, quateness. Historically, this word has been translated as unless, shaping our understanding of the law and how we perceive motion and force. However, a closer look at linguistic nuances suggests that insofar as or to the extent that might be more accurate translations. Now you might wonder, why does this matter? Well, it matters a great deal. If we accept this new translation, it could change our interpretation of Newton's first law significantly. Instead of stating that an object will remain in its state unless acted upon by an external force, it could mean that the continuity or change in any motion is contingent upon external forces. This isn't just a matter of semantics, it strikes at the very core of how we comprehend motion and force. If Newton's intent was to articulate that forces play a more active role in sustaining motion, rather than just altering it, the implications are profound. This reinterpretation could potentially reshape our understanding of motion and force interactions, prompting us to re-examine physical phenomena through a different lens. Could this linguistic switch truly stir the scientific community and potentially upend centuries of foundational physics understanding? As we continue this voyage of rediscovery, we may find ourselves revisiting the foundational tenets of physics with fresh eyes and new perspectives. So buckle up, because this journey is just beginning. What if the law of inertia isn't exactly as we've known it to be? A question that might seem like a mere thought experiment, but one that has the potential to redefine our understanding of motion and force. For centuries, Newton's first law of motion, a bedrock principle of physics, has been interpreted as follows. Objects in motion stay in motion, and objects at rest stay at rest, unless acted upon by an external force. This concept, known as the law of inertia, is deeply ingrained in our understanding of how things move or don't move in our universe. But what if we've been looking at it somewhat askew? What if Newton's original intent was not to suggest that motion or rest merely persists unless interrupted by an external force, but rather to articulate that the continuity or change of any motion is contingent upon external forces? Picture it like this. Forces don't just step in to alter motion or initiate rest, they're perpetually at play, actively sustaining motion or maintaining stillness. This isn't just a minor tweak in interpretation, it's a paradigm shift. It suggests that forces aren't just the disruptors of motion or instigators of rest, but the very sustainers of these states. This implies a universe where forces are not merely reactive, but constantly active, subtly shaping the motion of every particle, every planet, every galaxy. Such a reinterpretation doesn't undermine the centuries of physics built upon Newton's principles. Rather, it enhances our grasp of the subtleties underlying motion in the universe. It prompts us to re-examine physical phenomena through a different lens, to question and perhaps redefine our understanding of how motion and force interact. Could this reinterpretation reshape our understanding of motion and force interactions? It's a question that invites us to delve deeper, to reevaluate the words of one of the most influential scientists in history, and to revisit the foundational tenets of physics with fresh eyes and new perspectives. And perhaps, just perhaps, it's a question that'll lead us to a more nuanced understanding of the universe we inhabit. How might this shift in understanding impact our view of the physical world? Consider, for a moment, a universe where the law of inertia isn't as passive as we once thought. If our understanding evolves, it could fundamentally alter how we perceive the dance of planets, the flight of a bird, or even the fall of an apple from a tree. This reinterpretation doesn't suggest a rejection of the centuries of physics built upon Newton's principles. Rather, it invites us to re-examine physical phenomena through a different lens. It's like peeling back another layer of the onion, revealing a more nuanced understanding of the universe's motion. Imagine a world where forces don't just alter motion, but also actively sustain it. A basketball spinning on a finger, a satellite orbiting a planet, or a comet hurtling through space. Each of these examples of motion could be seen in a new light. It's not just about an external force initiating movement or causing a change in motion anymore. Now, it's about the continuous role these forces play in maintaining that motion. This shift in perspective could open up new avenues in physics research. It could stimulate fresh hypotheses, inspire novel experiments, and even lead to groundbreaking discoveries. It may provide a more comprehensive understanding of the complex interplay between motion and forces, enriching our grasp of the subtleties underlying motion in the universe. Moreover, this new interpretation could have far-reaching implications beyond the realm of physics. It could permeate into our everyday lives, influencing how we design and interact with technology, how we navigate our world, and even how we understand our own bodies. So, while the essence of Newton's first law might remain unchanged, the implications of its reinterpretation are profound. It's not about discarding old knowledge, but about building upon it, refining it, and seeing it with fresh eyes. It's about embracing the possibility that even in the seemingly immutable laws of physics, there is room for growth and exploration. Are we on the brink of seeing the universe through a fresh lens? It's a thrilling prospect, and one that could reshape our understanding of the physical world as we know it. So, what's next in this physics revolution? The intellectual adventure is just getting started. This recent debate around the reinterpretation of Newton's first law of motion, sparked by Olhar Digital, has opened the door to a world of endless possibilities. We stand at the precipice of a new era, where we're not only reconsidering a cornerstone of physics, but also how we approach the discipline itself. As we delve deeper into the original Latin texts that Newton penned centuries ago, we realize the power of language and its role in shaping our understanding of the universe. The word quateness, once thought to be a simple unless, now potentially holds a richer meaning, insofar as, or to the extent that. This shift in translation doesn't just change a word, it changes our perception of motion and force. This conversation is more than a linguistic puzzle. It's a call to revisit the foundational tenets of physics with fresh eyes and new perspectives. As we reevaluate the words of one of the most influential scientists in history, we're encouraged to think outside the box, to question what we know, and to explore the unknown. Remember, science is not a static field. It's a dynamic, evolving discipline driven by curiosity, argument, and discovery. Newton's laws have stood the test of time, providing a reliable framework for understanding the physical world. But as we dig deeper, we may uncover subtleties that enhance our grasp of the universe's intricate dance of motion. This reinterpretation is not about debunking established principles. Instead, it's about enriching our understanding, refining our models, and embracing the complexity of the cosmos. It's about the continuous pursuit of knowledge, the thrill of discovery, and the joy of shared learning. The journey of reinterpreting Newton's first law of motion has just begun. Where it leads, only time and science can tell. So, a single word has the potential to change our understanding of the universe. This is the intriguing realization we've arrived at today. A fresh look at Newton's first law of motion, the law of inertia, has revealed that how we interpret one Latin word, quateness, can significantly alter our understanding of this foundational principle in physics. The traditional interpretation of the law suggests that objects in motion stay in motion, and objects at rest stay at rest unless acted upon by an external force. However, a closer linguistic scrutiny of the Latin term quateness suggests that insofar as, or to the extent that, are more accurate translations, potentially shifting the law's interpretation. This implies a more active role for forces in sustaining motion, rather than just altering it. It's a fascinating notion, isn't it? That the continuity or change in any motion could be contingent upon external forces. This isn't just a scholarly debate over semantics, it's a profound shift in how we comprehend motion and force. If this new interpretation holds, it could reshape our understanding of how motion and force interact, prompting us to re-examine physical phenomena through a different lens. It offers a chance to enhance our grasp of the subtleties underlying motion in the universe. While this wouldn't invalidate the centuries of physics built upon Newton's principles, it could certainly give us fresh perspectives. The ongoing conversation around this reinterpretation is just beginning, and it's an exciting prospect to reevaluate the words of one of the most influential scientists in history. We invite you to keep an open mind, to question, explore, and delve deeper into this topic. Who knows? You might just find yourself revisiting the foundational tenets of physics with fresh eyes and new perspectives. Remember, even the most established principles may hold surprises. Stay curious, stay questioning, and keep exploring the wonders of the universe.